Here is a short video showing you how to use your calculator to draw the normal curves showing the probability distribution. So it's the kind of thing you might want to use in your math studies coursework. Here is some data. Could represent any kind of typical math studies coursework, so these might be reaction times or memory scores or pulse rates, or a bit low for pulse rates. So the boys have a higher average score than the girls, but the girls have more consistent results than the boys. So the question is, how certain am I that the boys' score would always be higher than the girls? Or is there a chance that I just happen to pick a random bunch of boys who were as good at memory tests as possible, and a random bunch of girls who weren't representative of girls on average and were poor at memory tests? So in other words, if I were to repeat this and pick another set of boys and another set of girls, how sure am I that the boys would always be better than the girls? So how sure am I that my sample really represents the population? So what we do is we go to y equals on the calculator, and I've already put the first one in to save time, and I'll show you how to put the second one in. So I'm going to put in the equation for the girls. I go to distributions, same as you would for a normal distribution question, except this time I'm going to go choose normal PDF. This is the only time you ever use normal PDF. All exam questions involve normal CDF. So we're going normal PDF. For the x value, I'm just going to put x, and it's going to update the x value as it draws the graph. For the mean, I want 22 for the girls. The girls' standard deviation was 0.2. And I'm going to paste that formula into the y equation. So now I've got my two formulas. There's the boys one, there's the girls one. I'm going to set up my window. The minimum value is usually about 3 standard deviations below the mean. So whichever one of these is going to give you the lowest, you take as the minimum. So 3 standard deviations below 22 would be about 21.4, so 21 is fine. 3 standard deviations above the mean, well, that would take me to 22.6, this would take me to 24.9, so 25 is a good enough estimate. For the y-scale, I'm dealing with probabilities, so somewhere around about 1. For the maximum value, I've chosen 2, so it just shows all of them. And all we do is graph it. So here is the graph that shows where the boys' results are likely to be. And here is the graph for the girls' results. It's got a smaller standard deviation for the girls, so you can see that impact on the shape of the graph. The girls' results, if I repeat this experiment, are pretty likely to be where they were this time. There's a small probability they could be anywhere between here and here, though. Boys' results could be anywhere between here and here. Now, because there's no overlap, there's virtually no chance that even if I choose boys who score as low as possible and girls who score as high as possible, that next time the result could be reversed, that the girls could score better than the boys. So in this case, I have a lot of confidence in my result to say that boys on average score higher than girls. However, suppose my results had been slightly different. Let's say the standard deviation had been greater, so the spread for the boys had been, let's say, 0.9, and the spread for the girls had been 0.6. Then if I update the graph to account for that, so the spread for the boys, the standard deviation for the boys is 0.9 units. and for the girls the standard deviation is 0.6 units. So I may have to change my window slightly. So the mean minus 3 standard deviations would now take me down to about 20. The highest mean plus about 3 standard deviations would take me up to somewhere around 27. Everything else as a first guess can stay fine. I may wish to come back and change this later on once I've had a first look at the graph. So now you can see the result of the increased uncertainty because of the increased spread. I'm just going to redraw that with a better Y scale, so I'll change it to 1 now I've had a quick look at it. So these two curves are much more spread out, which represents the increased variation in their result, which represents an increase in your uncertainty about, if you were to repeat this experiment, where would the mean be next time. So the mean's probably going to be around 24 next time, but there's a chance it might be way up here, there's a chance it might be way down here, because the standard deviations are greater. Now in this case, the two curves overlap. So there is a probability that if you repeated this experiment with a new set of boys and girls, next time you might get girls who scored here and boys who scored here. So the result might be reversed next time. So if this is what your results look like, you have a lot less confidence in the fact that your result really represents a genuine difference between boys and girls. And if that's the case, then you need to go on to, or you can choose to go on to look at something called the t-test to find out how much confidence you do have in your results. And there's a worksheet for the t-test on my webpage as well.